Hi, I'm Kian, and today I want to teach you how to find a formula for a series and find if it converges or diverges. So if you have this series, we don't know the formula, but the terms are square root of 2 over 2, the third root of 2 over 3, the fourth root of 2 over 4, and the fifth root of 2 over 5. So if you can see, we see that the power of the radical is increasing by 1. So the formula we can say is the sum, and because it starts from 2, we can say is n equals 2 to infinity of the nth root of 2 over n, because if you put 1, we get square root of 2 over 2, and we get 3, we get cube root of 2 over 3, and so on. So we have this formula for nth root of 2 over n. Now I want to see if it converges or diverges. So I want to show you two steps. One is direct comparison test, and the second one is limit comparison test. So first, for the direct comparison test, I want to choose a series that I know it converges or diverges. And for this series, I want to choose 1 over n, because if you use 1 over n, it's very similar and it's a part of this series. So I can take the sum from n equals 2 to infinity of 1 over n, and because of p series, because the power is less than or equal to 1, we can say this diverges. Also, we can say it by the harmonic series, because this is the harmonic series. And now we can form an inequality because this diverges, so we can say that the sum from n is equal to 2 to infinity of the nth root of 2 over n is greater than equal to the sum from n is equal to 2 to infinity of 1 over n. Now, because we're solving an inequality and both the summation notations are the same, we can cancel out these two. And using the cross product, we get n times the nth root of 2 is greater than equal to n. Divide both sides by n. We get the nth root of 2 is greater than equal to 1 for values greater than or equal to 2. And if we plug in, we see that this is correct. So we can see by conclusion that the series, the nth root of 2 over n, also diverges by the direct comparison test. Now I want to show you how to solve it by the limit comparison test. The limit comparison test. And how? So we have used our known and the original series to use the limit comparison test. So we should take the limit as n approaches infinity of the original, which is the nth root of 2 over n, divided by the known series, which is 1 over n. If we multiply both sides by n, this cancels. And what we get, n and n cancels, we get the limit as n approaches infinity of the nth root of 2. So we can write the nth root of 2 as 2 over 1 over n. We can make our work easier. The limit as n approaches infinity of 2 to the power of 1 over n. If you plug in infinity, 1 over anything over infinity is 0. So we get 2 to the power of 0, which is equal to 1. So, because this series, the limits of the quotient of these two goes to 1 and is not equal to 0, so we can say by conclusion that this also diverges, similar to the series 1 over n, by the limit comparison test. Thanks for watching. Please subscribe and let me know what to do next.